All right, so next we're taking a look at 4.3, which is exponential equations and functions. So once again, we're trying to solve these equations. And you're welcome to use either of the skills we have about rewriting the base or your logs. So for this first one, I always start by isolating the base. So divide both sides by 64, such that base of 4 will be isolated. So we have 4 to the 3x. Probably it's going to be easiest to leave this right side as a fraction, which simplifies to 1/4, because then I think you'll see the relationship a little better. Not to say you couldn't call it 0.25, in which case you'd probably use log if you did. So now, I probably, since this is base 4 and this also has a 4, just rewrite the right side as base 4. And what power of base 4 goes 1/4? The negative first. So therefore we get 3x equals -1, and then when you divide both sides by 3, x equals -1/3. Same idea on this next one. We want to get this base of e all alone, so I'm going to divide both sides by 1919. So we get e to the k plus 4 equals 13 over 1919. And this one I'm like, I don't really know e to what power equals that fraction. And is there even an integer power where e would be equivalent to that fraction? The answer is no. So here I would use your definition of log. So log base e, you can think about doing your e thing, like log base e of that fraction equals that. But log base e, remember log base e is the same as natural log. So here we're really talking about natural log of 13 over 1919 equals k plus 4. And then we want to go ahead and get k all alone. So we are going to subtract 4 from both sides. And here is our answer. Okay. Let's do 1 or 2 more together, and then I'm gonna leave you guys to it. So let's try C and then F, and I'll give you the answers for D and E. So let's look at C. Same idea, we wanna get this base E all alone. So we have e to the r plus 10, add 10 to both sides equals -32. So you need to think about taking the natural log of both sides or just using that definition, whatever you like. So natural log base e of the answer of -32 equals r plus 10. So natural log of -32, we gotta subtract 10 from both sides equals r. Okay, you're all good to go, must looks great, I got an answer, but be careful what's true about that input. Remember the input must be positive for a log. So therefore, we can't actually have that as our solution, right? Because we wouldn't have a negative input, so this one is actually no solution. Okay, even though I'm not going to go over D and E, I recommend trying it. On D, you should get x equals log base 5 of 36. And on E, you should get x equals 7 times log of base 3 of 4. Okay, let's look at F together though. So we're gonna have, probably just put everything on the same side, see what we recognize. So 2e to the 2x, I'm gonna subtract e to the x and subtract 6 equals 0. You could have moved the e to the 2x to the other side. You're like, well, that's kind of funky. Even if I left 6 on the other side, I still have these e to the 2x, and it's not like you can factor one out. But notice, I don't know if you guys remember from last chapter, when you've got hey, we got something squared, and then we got this other term, we got a constant, you've got it. Remember our friend, let u equal, such that we'll be able to have a quadratic. We're looking for this to be u squared. So, if we think about that, u squared is e to the 2x. So if we just had e to the x as u, we'd get squared, then we'd have minus u, minus 6 equals 0. So what multiplies to 6 and adds to -1? You've got a -3 and a +2. So u equals 3 and u equals -2. And then we got to plug things back in. So e to the x equals 3, e to the x equals -2. Whether you use your definition or think about taking the natural log of both sides, we get the natural log of 3 equals x. The natural log of negative 2 equals x. One of these you should notice an issue with, and that is this negative input, but this positive input will still work. All right. I'm gonna actually skip this next example as we have lots of these in 4.5, so I'm not gonna worry about it as much here. Okay, but let's talk about graphing exponentials. So whether it's a law, I guess these are all exponentials. I think we go to graphing logs the next section. They suggest finding the domain. And just for the record, remember like 2 to the x? It looked like this. Your domain is generally negative infinity to infinity, and the range is usually 0 to infinity. Okay, find the x and y intercepts. It applies the same way as we did before, like x-intercepts at x equal to 0. Y-intercepts at x equal to 0, evaluate for y. X-intercepts at y equal to 0, solve for x. You can look at transformations, but in general, if you know a few key points, you'll be good to go. As for asymptotes, remember it's usually y equals 0, it's that x-axis, but then if there's been any shifts, particularly up or down, then it will impact that. So, in general, let's take a look at this first one. We've got a shift of up 2, and we've got e to the negative x. Remember this negative x is going to reflect it, specifically in this case, across the y-axis. Okay. In general, e to the x is similar to like 2 to the x, so it looks something like that to begin with. Okay, so our domain hasn't changed. It's still going to be negative infinity to infinity, but our range is usually from 0 to infinity, but now since we moved it up 2, it's now from 2 to infinity, meaning our horizontal asymptote is also at 2. For an x-intercept, you kind of are asking yourself, well, if 0 equals e to the negative x plus 2, I subtract 2, so negative 2 equals e to the negative x. Well, what do you notice here? You're like, natural log of negative 2 equals negative x, but I can't do natural log of a negative 2, so there is no x-intercept. That doesn't exist, which makes sense because we shifted it up, and it wasn't crossing the x-axis to begin with. But your y-intercept, if I plug in 0 and do like e to the negative 0 plus 2, well, that's just 1 plus 2, so the y-intercept is at 3. So you've got a y-intercept at 3, we've got this asymptote at 2, and this time, rather than curving to the up, it curves down. Right, so it's going to look something like this. You can always plug in another point if you wanted to and kind of have a decimal approximation on your calculator. Okay, let's look at the next one. This one, in general, 1/2 raised to the x is going to be a decreasing graph, like a decay graph, so it'll look like that. In this case, this plus 1 in the exponent, think about that being like in the parentheses, is going to move it left 1. And this negative out front reflects it over the x-axis this time. So our domain hasn't changed. Even moving it left is not going to change the domain. Your range, though, if it generally goes from 0 to positive infinity when we reflect it over the x-axis, it's now from negative infinity to 0. We will still have the same y asymptote at y equals 0, because shifting it right and left is going to influence that. If we have an asymptote there, you could probably logically just say to yourself, hey, there's no x-intercept, but you can always, convince yourself as well by solving, setting y equal to 0 and trying to solve for x. There's not, a half raised to some power will never give you 0. However, if I plug in 0 and I do negative a half raised to 0 plus 1, I do get negative a half as my y-intercept. So I got negative a half as my y-intercept. I got my asymptote at the x-axis. You're welcome to plug in some more points. For example, if you plug in negative 1, we end up with negative 1. If I plug in negative 2, I end up with negative 2, etc. So your graph ends up looking something like this. Okay, one last one. This dividing by 2 does make it a horizontal stretch, which I know are hard to understand, so always use as a backup like plugging points. However, this minus 3 is going down 3, and that one you should recognize. Once again, our domain of negative infinity to infinity will not be influenced, but our range will be. If I moved it down from 0, 3, I'm going to be at negative 3 to infinity, meaning my asymptote now is at y equals negative 3. So let's see if there's an x-intercept. We're saying 0 equals 3 to the x divided by 2 minus 3. Add 3 to both sides. Whether you use your definition of log or you say, oh, hey, well, 3 to the first is equal to 3, and then you said the exponent's equal. Either way you do it, you should get your x-intercept is at 2. Then if you plug in 0 for x, we end up with 1 minus 3, we end up with y is equal to negative 2. So we got a negative 2, we got a positive 2, we've got our asymptote here. It is growth, so it is curving up. All right, that's a brief recap, or like overview of 4.2.